All right. Well, our next speaker, as I mentioned, is bringing us into the ocean during the time of dinosaurs, and just over the border to the north of us. Dr. L.J. Krumenacker is a affiliate curator and researcher at the Idaho Museum of Natural History, and also an adjunct professor at both Idaho State University and College of Eastern Idaho, and is going to talk to us about a really spectacular fossil deposit with soft tissue preservation just north of us. Take it away.
Cool. Thank you, Randy. Thank you guys for coming. So apology in advance. It's not dinosaur related, but this stuff is just as cool as the dinos. Okay. To start off, we've got to go right before the age of the dinosaurs. So we'll go to the very end of the Paleozoic to set the scene. You guys have probably heard of the end Cretaceous extinction that killed all the dinosaurs. That really sucked, but there was one even worse, called the end Permian extinction. 252 million years ago, it's what ends the Paleozoic era. There was this extinction event, the worst in the history of the planet, as far as we know. It's called the Great Dying. Depending on your sources, it killed about 80% of everything in the ocean, 70%, give or take, of everything on land, or if you average that out, about 83% of all living genera of animals. So this was a very, very bad day. It's thought that this was probably caused by climate change related to volcanic activity in Russia called the Siberian Traps. And it looks like this caused runaway greenhouse effect, environmental catastrophes, acidification of the ocean, and food chain collapse. Again, very, very nasty. So that's the depressing part. But what we're going to talk about is how life recovered right after this. We're going to start off in the early Triassic, about 251 million years ago. To give you a little background, so scientists have for a long time been interested in how animals recovered from this extinction event. As I mentioned, it was the worst in the history of the planet, and there wasn't a lot of information known about it. Up until recently, the best information we had came from a place known as the Luping Biota in Luoping, China, if I'm saying that right, in southern China. And this is a great fossil location. This is a Lagerstadt. I love Lagerstadt. Those are areas where you get special fossil preservation, where you get good quantity and or quality of fossils. In the Luping Biota, you have things like this ichthyosaur, you can see right here. You got this fish, Saurichthes. Got horseshoe crabs, other arthropods like this shrimp. You've got plants, and I forget what this is, maybe a sponge, but lots of different organisms in the Luping Biota. And the Luping Biota occurs about 10 million years after this worst extinction in the history of the planet. So to set a little bit more background. So ever since I was about my son's age, I've been a fossil nerd. I just like to go out, look for fossils. That's how I got into paleontology. One day when I was an undergraduate at Idaho State University, I decided to take the day off and go out for a fossil hunt. I read about a shark spine that had been found in the mountains of southeast Idaho down near Bear Lake. And I went up this canyon to see if I could find anything cool. So you can see the outcrop right here. There's these shaly limestone layers that I found. And I started to find some weird fossils, nothing super fancy. If you look down here, you can see an ammonoid. What really got people interested, though, is this mystery fossil here. If you can see in the red box, it doesn't look like much. It's a wormy looking thing. I couldn't tell what it was. I'm generally a dinosaur nerd. I had this sitting in my fossil collection for 10 years trying to get people to figure out what it was. And no one at ISU knew where I was doing my undergrad at the time. No one else that I showed it to knew anything. And I was like, well, I'll just keep asking people. So lo and behold, eventually, I've got two ammonite friends sitting in the back here, Kevin Byland and Jim Jenks. I showed this pictures of this fossil to Kevin and Jim, and they showed it to Dr. Arnaud Briard in France. And it turns out that this weird little wormy fossil is a sponge. A few different things about fossil sponges. Usually they're rare because they're soft and gooey, minus their little spicules that make up the skeleton that get blown all over the place after they die. But these were complete little articulated sponges. So that was one thing that turned out to be interesting, is usually it's hard to find a good complete fossil sponge. The second thing that got Dr. Briard's interest and other members of what we call the Paris Biota team is this sponge belong to a group that supposedly went extinct way back in the early Paleozoic in the Ordovician, about 480 million years ago. And here we have this sponge in rocks that's 250 million years old. Other random thing, when I went to this spot, this has never happened again and it drives me crazy, but I went there one time. It's like the second or third time to this spot. I parked my car, I got out, I walked up to a rock, I hit it with my hammer, and out popped 6 shark teeth. You can see right here. Because they got popped out that way, they weren't in the perfect shape, but they were still pretty good. I have never had that happen again. And I've gone there, I was like, I want to find more shark teeth. And I've gone there like 15, 20 times. But that was cool. So that showed that this spot was important. And we started to find little fossil shrimp. You can see this fossil right here. This is a little shrimp, and that's great that I don't even have a scale here by the scale bar, but it's about a little less than an inch long. And shrimp, usually you don't find fossil shrimp because arthropods like that are a little bit softer, give or take, than other organisms and don't preserve well. But we started finding lots of shrimp and lots of sponges and the shark here. So Dr. Breyer and Kevin and Jim decided this is a great place that we all needed to go out and start doing a whole bunch of research. So to tell you where it is, the title of this talk, we are nowhere near Paris. We are not near Chateau Picard. I had to throw that in, okay? We are in the metropolis of Paris, Idaho. Anyone been to Paris, Idaho? I'm just curious, raise a hand. So we're not that far, okay? Cool. So it's just west of the town of Paris in a canyon up there where we get this fossil location. About 250 million years ago, we would have been just off the west coast of Pangaea in a shallow oceanic setting. Here's a nice paleogeographic reconstruction from Ron Blakey. I've got the red box, same thing. You can see the fossil location is right here in the middle of the red box. And again, we're in this inland embayment on the west coast of Pangaea about 251 million years ago. These rocks are called the Thames Formation, by the way. Thames Formation outcrops, I think just some are pretty close to town in the mountains east here. It outcrops in western Utah. It outcrops all over southeastern Idaho. And it's in the lower part of the Thames Formation. The rocks are about 251 million years old. We call this the Paris Biota. It was near the equator at the time, and it was fairly shallow water. And what makes the Paris Biota really important, if you remember the Lupang, I can't pronounce it, the biota from China was 242 million years old. This is 251 million years old. This is just over a million years after that worst extinction event in the history of the planet. So it's turned out to be really important because it shows us how quickly life was able to recover and diversify after this point where 80% of everything snuffed it. So all the different fossils we get in the Paris Biota. We get 7 different phyla, over 20 metazoan orders. Again, this is a Lagerstadt. If you guys, you probably have heard of the Solnhofen limestone in Germany with all the nice Jurassic birds and arthropods and stuff. I like to think of this as Idaho's equivalent of the Solnhofen. We haven't got birds, but we've got all these cool arthropods and starting to find some fish in there. And to me, that's really exciting. Everything that I have in the red box right here are organisms that we find in the Paris Biota, right in this main outcrop. We've got bivalves, so basically clams. We've got ammonoids, your Mesozoic poster boys. We've got orthoconic nautiloids. We've got other cephalopods. We've got these sponges. We've got different arthropods, brachiopods. We've got turds, AKA coprolites. We got sharks. We got fish. We got algae. This is an absolutely amazing spot. Certain things that are really important from this spot. So it's a first appearance of some taxa in the fossil record. First appearance of coleoids. These are your soft-bodied cephalopods, meaning something like a cuttlefish that actually has like that cuttle bone you put in your bird cage on the inside. But the coleoids don't have an external shell. You get your ophiuroids, your little brittle stars. These are some of the first occurrences here in the Paris Biota. Then we get this sponge that I mentioned that supposedly went extinct 480 million years ago, and here we have them in 250 million year old rocks. These are called a Lazarus taxon, like out of the biblical story where Lazarus is raised from the dead. You can see my little image right here. So here's where supposedly that type of sponge went extinct 480 million years ago. Here we have it at 250 million years old. Pretty stinking cool, I think. So I'm going to walk you through just the different animals we got there. It's a great diversity, and I love it because it's a great ecosystem right at the beginning of the age of dinosaurs. So I mentioned these teeth. We have these teeth from a hybodontid shark, it's called. I'm going to spitball here and say he was maybe about 3 feet long. He's not a big shark, but a shark is a shark, in my opinion. They're pretty cool. All these teeth represent one individual in this slab of rock, and they're about 1 centimeter long. They are super, super rare, those sharks. We have lots of isolated fish bones from this area as well. One of the best specimens you can see down here, this is a tooth plate or a part of the palate of a shell crushing fish, similar to this guy called Biota. I don't know if any of you guys, if you've ever cooked some fish, noticed how many bones are in a fish. That's one reason I work on dinosaurs, because if you find a single fish bone, it's so stinking hard to tell what the heck it is. We get lots and lots of isolated fish bones from Paris Canyon. In other places in the same layer of rock, we're starting to find some nice articulated fish. It's pretty stinking cool. You can see that one right there. It's called Biota, and I'll go back to him in a minute. Coprolites, okay? So coprolite is a fossil turd. They are fairly rare at this location. The biggest problem with when you find a coprolite is you have to wonder who dung it. There you go, okay? It's hard to tell, okay? You have to know what's in it. In some of these coprolites, you've got little cephalopod hooks from their arms. So it was something eating those guys, but we're not sure. Most of them aren't too big, but they can get up to about 1 centimeter or 2, the ones I've seen there. We've got the very base of the food chain. We've got algae. You get fossil algae at this location, which is not exactly usually super common. It doesn't look like anything special, but having it preserved there shows we've got that primary producer forming the base of the food chain. Some of the most common fossils there, these little orbiculoid brachiopods. So they're not a clam, but they're a similar sort of a shelled animal that lived in the ocean. And you can see this little one right here. They're pretty stinking small, maybe 1 centimeter length. We also get lingualid, if I can pronounce it right. Whoops, I bumped something. We get other brachiopods like the genus lingualis that you can see here. And then our sponges. One of the cool things about the Paris Biota too is we got 7, if I remember right, at least 7 new species we got to name from this location. We put out a whole big treatment on the Paris Biota. It was pretty cool to be able to help with that. This is that same sponge, just if I remember right, is that very first one I found that I showed to Kevin, and I was trying to figure out what the heck it was. But this sponge is named Pseudoleptomytis adventis. They're a few inches long. Again, they look like these weird wrinkly worms, but they're actually these sponges that were very common on the ocean floor at this time. Ammonoids. Everyone loves ammonoids, hopefully. I love ammonoids. We have a new species of ammonoid from this location named Albanides americanus. This is one of the most common fossils at that location. They're not super well preserved, but there's a whole lot of them. You can see the artistic reconstruction right here. Coleoid cephalopods. Those are, again, your cephalopods that have an internal skeleton. This is a new species named, if I can stop bumping the thing, Idahotuthis parisiana, okay? And you can see on the bottom here, this is that internal gladius, it's called. It should be something like these squid right here. Orthoconic cephalopods, so many different cephalopods here. These are cephalopods that had an external shell that was straight. These are rare, but we'll get those there as well. Biggest ones I've seen might be a few inches long. I love these guys. These are like the things of your nightmares. Imagine if it was the size of a bus. They aren't, but they are about 2 inches long. These are a type of arthropod called a thylacocephalin. On the left right here, we have an example, and what we get preserved are the shells of the organisms. If I recall correctly, these organisms were not known from the Triassic of North America until we started finding them in the Paris Biota. But they'd have this weird shell, these giant alien eyes, and these big raptorial appendages. These things are so stinking cool. I love them. Like I said, we've got 2 new species from the Paris Biota of these thylacocephalins. Lobsters, more arthropods. Okay, how many guys in here like to eat lobster? Just curious. Okay, these would not go very far. Mostly we find the tails that are maybe 1 to 2 centimeters long, but we find a lot of lobsters there. Shrimp. One of the coolest fossils I've seen from this location is a slab that the team found out there covered with dozens and dozens of shrimp. There's 2 kinds that we see there. We haven't got them named yet. I'm not going to pretend to know a lot about shrimp, but I think they're pretty cool. You can see the examples right here. And on the lower left right here, you've got the tail to the right. You've got the head and all the appendages to the left. It's about 2 inches long. Starfish, these things are stinking cool. I think they're very, very rare at the Paris Canyon location. But this is another new species that we got to name, Shoshinura. That is a little brittle star. You can see right here. And other echinoderms. So these things are called crinoids. They're related to starfish. Again, they're echinoderms. They've got like 5-fold body symmetry. These things look kind of like flowers that grow on the ocean floor. And they would filter feed. They'd take food in from the water and just sit down there and look pretty on the ocean floor. So that's the basic with the invertebrates that we find there. Talk a little bit about the preservation and taphonomy. As I mentioned, I love a Lagerstadt. Things like the Solnhofen limestone or the Bear Gulch limestone, if anyone knows that. I love these things where you get a big picture of an ecosystem. There's been a little bit of taphonomic research trying to figure out why we get this soft-bodied preservation here with the complete sponges and these shrimps. So far, it looks to have something to do with the original chemical composition of the animals, as well as the presence of the clays and the minerals that these animals were buried in. One nice way to get a better idea of what these specimens look like, you can do multispectral analysis. I absolutely love this image again on the right of the shrimp. You can see where that's been imposed multiple multispectral analysis to make this right here, but it's pretty easy to see your little shrimp with his head and his abdomen carapace back here. So why does this matter? Okay, so I mentioned this was right after the biggest extinction in the history of the planet. This is a great way to understand how quickly life bounces back or doesn't after a huge extinction event. Since we found this location in Paris Canyon, the Paris Biota team has found other locations in the same layer of rocks near Georgetown, Idaho, and canyons near Soda Springs, and you'll get the same organisms there. What's really got me excited though, like I say, I'm a dinosaur guy. I understand animals with bones a little bit better than some invertebrates, but in these locations, we're starting to find complete articulated fish, which gets me super excited. I think fish are cool. We'll find more arthropods, sponges, and a few little bits of marine reptiles are starting to turn up. My big goal, what I want to do in the Thames Formation, hopefully starting this summer, is I want to look for things like the big ichthyosaurs, the big top tier predators. They were probably there, but we haven't found a lot of evidence yet, though Jim's found some ichthyosaur bits, I believe, in the Thames too. And to me, it just suggests there's a lot of potential. So the whole caboodle here, I absolutely love this reconstruction here. We've got our crabs and lobsters like we have our brachiopods, we have our purple Lazarus taxon sponges, we have our freaky deaky thylacocephalin arthropods, our sharks, our ammonoids, our different sorts of other cephalopods. And at the top here, we haven't found an ichthyosaur right in the Paris Biota in Idaho yet, but I want to keep looking. I suspect there's going to be something there. We do have in a new paper that just came out last year, we have found examples of the Paris Biota in Nevada now showing the same sorts of organisms. And if I remember right there, they did find an ichthyosaur vertebra. So I think there's a lot of potential here to understand how life bounced back after this extinction. And I think it's pretty cool. So there you go. Quick thanks to Kevin and Jim, who really helped me understand how important this was and helped a dinosaur guy learn a little bit about ammonites, which is great. Thanks to the whole Paris Biota team, Bear Lake County that lets us work out there, and Dr. Breyer. So now I can take your questions. So.
So it seems like there's a pretty amazing diversity of cephalopods specifically. Any particular reason why you think that might be?
I will spitball here and Jim and Kevin can tell me if I'm wrong, but just at this time, there was a great opportunity for them to diversify. And some of these things were common in the very end Permian as well. And I think there are some of the things that made it through, so. Mm-hmm.
So some of the things, you get full body preservation, but then other things you're only getting partial preservation, like on the lobsters and things like that.
Mm-hmm.
Do you think that is because, they were like eaten apart and like we're seeing pieces, or do you think there was something about those guys that just didn't allow them to preserve all the way?
I would suspect it's a mix of things. So you've probably got predators taking care of some of that. Like it drives me crazy at the original Paris Canyon location. We'll just find disarticulated fish bits. So I think there are a lot of animals being munched on. And also it'll just be the vagaries of fossil preservation, who happened to get covered and buried quickly after they died compared to who didn't. Plus, you can think of some of those things that were benthic living on the ocean floor. It seems like there's a bias towards those guys getting buried better, from my slightly educated opinion there. So.
How many trips have you taken out to this site, and do you find something new every time?
I've always been a fossil nerd if I had time, but I've probably been out there 20 times. And the more you go out there, the harder it is to find something new, but every once in a while still you'll find one of these weird arthropods or something. So easiest things to find are the ammonoids and the bivalves. Hardest things to find are some of the arthropods and the fish, but I mean, it's always fun just to go back. So.
So you were saying those sponges had been thought to have gone extinct in the Ordovician. Have they since then, between the Ordovician and the Triassic, found any more of that sponge?
Not as far as I know. So it's a good ghost lineage.
Huh.
But then, I mean, sponges are hard to preserve, so I'm not super surprised, but I'm sure people are going to be looking for that now. So
Does that imply maybe that they were hardier than we thought?
I would expect so. I can't claim a lot of sponge knowledge still, but I think that's pretty reasonable. So.